Hope you're ready for the second part of this orchestrating generative AI applications live stream. Maybe let's start with a recap on what we have done last time, and then we can continue implementing it and hopefully also finalizing it today, because I want to do another topic in the next live stream. All right, let's do a quick recap. So what have we done until now? We have built an application where we can generate a recipe, and the recipe is stored on a Google Cloud Storage bucket. And to orchestrate this, we have used the Google Cloud workflow. And today we're going to extend this a little bit by adding the image generation part to it. Last time we already started implementing this, but we have seen issues with the limitations around cloud workflows with the HTTP response size. So we need to migrate this image generation service to a Cloud Run service and then call it from the Google Cloud workflows. So that's what we're going to do today. So we deploy this as a Cloud Run service and then we connect it with the workflow. If you want to follow the code, you can check this out on GitHub. So no need to do this all today. There's no need to do that while I am doing it. Do it in your free time. You can go to GitHub. You can get the code there. Also, this video will be also uploaded to my YouTube channel. So the previous recording is already there. You can rewatch this if you missed the first part, and then you can continue with the second part later today. I will upload this in a couple of hours. All right, let's first go to the code and actually run it. And you see, for the people joining for the first time, that you can see what we have built last time. So we go to GitHub again. We're gonna take this gcloud workflows deploy script or command. That's how we can deploy this cloud workflows recipe. In this case, our recipe workflow. So I have this orchestration repository here, where we have the, that's what we're going to build today, where we have the recipe.yaml, and from there we can, our workflow here, you can see we have the different steps, what we have done last time. So we call it Gemini model, we pass it, and we upload it to the recipe.yaml exactly. So let me go to this one, right folder. So let's first deploy this again, this recipe. All right. And then we generate a recipe. Because it's morning, we generate some breakfast. Let's take a healthy breakfast. All right, generate this. Looks good. So let's go back to Google Cloud, and then we can have a look at the recipe again, and then we continue doing the stuff we stopped last time. So I have this bucket folder here. Oh, sorry, let's refresh. And here we now have our recipe. We can download that as well and open it up again in Visual Studio Code. So let's open this up here. You can actually also check the output here. Let's see. Where's the download? There we have it. All right, let's format this. So this is how it looks. So we get our recipe here. All right, let's go back to Visual Studio Code. Yeah, first people joining the chat. That's great. All right. So let's continue the work from last time. Let me quickly restart my Visual Studio, because it somehow lags here. All right. We get this back into the coding view here. Just 1 second. So let's go into the recipe again. So what we're going to do today, and I already started with the implementation last time to save us some time today, but I go over the code I implemented. So last time we stopped here, so we generated this image with Imagine, and today we're going to deploy this service to Cloud Run to actually get an API endpoint. And to do that, I use Flask. So in this case, I import Flask because we want to put this behind an API endpoint to actually be able to call this API endpoint, either from somewhere else, but also from Cloud Workflows. It's great if you maybe have a service which you want to use as part of your Cloud Workflow step, but maybe also different teams, different applications want to call this, so it always makes sense to deploy this behind an API endpoint. And for that, I use Flask. You see, we have just one endpoint here. In this case, we are using the main path. We're using a post method. And here we generate the image. And we also save the image into the Cloud Run memory. And from there, we upload it to our Google Cloud Storage bucket. So it will be uploaded to the same location where we also upload our recipes. And you see, we define the bucket name. We also define the subfolder in this bucket. And we also define, we take the same UUID like we have with the recipe. So if we go back to the bucket, you see our recipe has a JSON file here. That's what we're going to use for also writing the image recipe to the cloud storage bucket. And this way we have the same ID for the recipe, the same ID for the image, and I don't need to put any reference of the image into the JSON. We can just tell the application, okay, this same UUID has an image and also the recipe JSON. And we upload this to Google Cloud Storage. For that, we use the storage client SDK. I'm doing this here in Python, but those libraries, those SDKs for generating the image, for uploading it to the Google Cloud Storage bucket, they are available in basically almost any of the most commonly used programming languages. So you could also do this in Node.js, in Ruby, in Go, whatever you're using it at your work or privately. And in the end, we run this as a Flask server, and we need to define a port, which we're getting from the environment for Cloud Run. We call this 8080, and we run it on a local host, so 000. That's what we have done here. And you see the prompt for generating the image is coming as a parameter to this API endpoint. And also the unique ID is also coming as a parameter to this endpoint. As a next step, to deploy this to Cloud Run, we need to build or create a Docker file. It's not too complicated. We just use because we're using Python. I take Python 3.8 Slim. It's just a smaller Docker container, a smaller base image. Don't need to use the full Python. Smaller version is enough for us. And then we install the dependency. So we're using Flask for the API. We're using Google Cloud AI Platform, which is basically could also use Vertex AI for generating the image. And then we use Google Cloud Storage for uploading the image to Google Cloud Storage. So those are the packages we need. I always recommend to pin down the versions, because when I'm deploying it now, it might be 2.17, but if I don't have this version defined, so let's assume we have this here, and I deploy in a couple of weeks again because I changed something, there might be a new version and there might be breaking changes or some changes I'm not aware of, and the application could fail. So I always recommend to pin down the versions here and make sure if there is a need to upgrade the versions, you can test it beforehand and you're not breaking your production environments. You can just simply go to search for pip here, go to the pip website, and here you get the latest version. That's usually where I grab it and I see if the packages work well together, and I stay with the latest version. And only if I see there's a change, for example, if Vertex AI or Google releases a new feature for the SDK, I upgrade, I test locally, and I'm sure if everything still works as expected, I can change the version manually here, upgrade it to a higher one, and then we can deploy it. So we also copy everything which we have in this folder here on the right side, which is part of our application. And then we run the main.py. So it's a very, very simple application indeed. Also for requirements txt, so we could, at some point later on, we should move this here into the requirements txt, because if you want to install this locally, it's easier for you if you use the requirements, and a Docker file just simply is referring to the requirements txt. But I do that in the next step. To deploy this application, I could now locally run Docker build, Docker push, and gcloud deploy. But I'm a big fan of cloud build because it automates a lot of the stuff. And if you later on want to deploy this yourself, you don't need to do all the manual stuff, all the manual gcloud commands or Docker on your local machine. You can just do everything on cloud, and cloud usually works way better. And for that, we have a 3-step process. So this is a cloud build YAML file. And here, first we build the Docker container. You can see we're running, we're using a base image, which is called Docker build. So Docker build, and then we push it to the Google Container Registry. Quick reminder here, the container registry will be deprecated very soon. So we need to migrate this to the artifact registry at some point, but there's a smooth migration process, so I don't worry too much now using something which is soon deprecated. There's also the next step we need to push. After we're creating the Docker image, we need to push it. And after that, we are deploying it to Cloud Run. So using gcloud command, run deploy, give it a name, and also give it an image from the container registry. That's what we have done in the previous step here. And then there are a few parameters. It's the region you can define, and also if it allows unauthenticated. I have this unauthenticated now, so you could give this a try yourself if you would like to. But yeah, if you put something in production, it should be always authenticated, and then you do proper authentication just for demonstration purposes now. All right, let's do this. How can we actually now build this application? We can use the cloud build YAML. So we run gcloud build submit, and then we are defining the dot means run everything in this folder, but I see I'm in the wrong folder. So I first need to switch to services image. That's where we have our Cloud Run service located here on the top right, and then we run gcloud build submit, and please build this folder. This command will look up for a cloud build YAML, and if it's finding one, it will take it and run the steps. You could also define the file yourself if it has a different name. Maybe you have one for development, one for staging, one for prod. So you could have multiple ones here. So I'm running this in this folder. This takes a few minutes, and while this is building, we can actually have a look into the cloud build process. So let me go back to Google Cloud quickly. Sorry, need to check this here. So I need to blur here again. All right. So opening up Cloud Build for you, so you can see how it looks in Google Cloud. Should be fine here. Yeah. So this is how you see the cloud build here. You see our multiple step process. So first thing, we are building the Docker container. This is now all executed inside of Google Cloud, which makes it very nice. So you don't need to Docker locally. You don't have any issues with Docker maybe running locally. Just do this all on cloud, and it works fine. I can have multiple builds in parallel, and I don't mess with my local environment as well. So this takes a few minutes. You see we're now first downloading all the dependencies we have, and it's already built, it's already tagged, and here it's already being pushed. So it's currently being pushed to the container registry. So now it's done, and it also deployed the Cloud Run service. We come to that in a second. First, let us also go to the container registry. You see we have it named, we scroll down, called image generation. So if you go here to image generation, you see we have it here in the container registry. All right, let's also go to Cloud Run. Let me reload this. So we should now see the service here. Image generation. So here we have the service. And it's up and running. So it's now behind this API endpoint. This is where our Flask application is now running. We could give this a try. I can also test this locally. I have this sample request here, but we can also test it on the cloud. So we need to provide a UUID, and we also need to provide a prompt. So let's we call it prompt. So generate a breakfast recipe. All right, the URL should be the same, just in case. Let's copy it again. Oh, sorry. Place that here. Yeah. So if we go back to the Google Cloud Storage bucket, let's refresh it. We only have the recipe from before. We are not having now the full pipeline, so we're only generating an image with some dummy UUID, but I think that should be enough for testing here. So UUID, prompt parameters are correct, like we have it defined in our sample here. So let's run the sample request, so sh sample request. Let's see if this is working. Takes a few seconds now to generate the image. All right. So we are getting the image size back, which was the issue from last time. So it's too large to directly use with workflows. That's why we host this in Cloud Run, and we are getting the destination. So we should now have an image here. There it is. Let me open up the preview here. So we are getting some breakfast here. All right. Next step. Now we have it up and running in Cloud Run. It scales up and down automatically. So depending on the number of requests you are getting, it can generate images, obviously limited by the imagine quotas, but you can request the quota increase there as well. So let's take this and combine this with our recipe. So what I have done here since last time, I updated the code a little bit. So the first thing, we generate this unique UUID for our recipe. We need to do this because we want to have the UUID for our recipe JSON and also for our recipe image. So we need to generate this for use later on in our workflow. Assign, we do this as an init step, just one step in our pipeline, which I call initialization. We have assign. Assign means we are creating a variable, which we can use through our code. And we call this recipe ID. And if we're actually searching for this, you can see, if we scroll down, we use this recipe ID when uploading the Gemini generated recipe to Google Cloud Storage. That's where we use it first. And we also use it when calling the Cloud Run service, which is now the next step in our pipeline. That's where we stopped last time. So now we have this generate image step as part of our pipeline. It's calling HTTP post, just as defined in our Cloud Run code. And we are calling the URL as we got it back after our deployment. There is a way to retrieve this automatically, which makes sense if you have different environments and different projects. So we could retrieve this with a name. I'm going to extend this very soon. And as parameters, we have our recipe ID and a prompt. The same I just used in our curl. So if you have your UUID and prompt, keep that in mind. And we go back to our code, which generates the image. You see we are getting this from the parameters. That's how it is. That's how the connection between cloud workflows and Cloud Run is made via this API. And then we're providing the parameters. All right. And additionally, I also added this image generation response, where we are just returning, as part of our workflow step, we are returning the full recipe. but we are also returning the image generation response, and I also want to have the usage metadata, so I can see how many tokens did I actually use for generating the recipe with Gemini. So let's take this again. Yeah, so we deployed it already, but I redeploy it now. Wrong folder. So let's redeploy it. Let us clear the Google Cloud Storage bucket. Recipes. Let's clear this. All right, so it's deployed. And now we can generate a recipe again, or generate a typical Italian dinner. All right. If you have ideas, you can post it in the chat. So if you want to get your own recipe generated, just post it in the chat, and I can paste it here, and then we might get a few nice recipes. So let's give this a try. I can actually go back to workflows. So it's called recipe. So this one is currently running, and the steps are already done, and currently it's generating the image, and it's done. If you have a look in the output, you see what I just mentioned. Let me put this to the side here. This is the response we have defined as our workflow. So we're getting the image generation response, which I return the destination path. We might need to use this later in another step. That's why I return it. And also the image size, because it's quite interesting. We get our recipe, our full recipe. And if we scroll down, we get also the usage metadata. So we see this used 718 output tokens and 5 tokens as our prompt. So total 723 tokens. Oh, it's quite a small token count. All right, let's go to the bucket and see if we already have. Yeah, so we have a JSON in our image. Let's open up the image again, see what we got here. All right, looks somehow Italian for me. Got some noodles, get some meat, some aubergines probably. Looks not too bad. Probably a little bit artificial, but that's fine. And also check the recipe again, what we have been generated. We can also do this in our workflow. Let's see. Antipasta, pasta, and some dessert. All right. You see, I'm also generating the recipe image prompt as part of our Gemini output. So if we're going back to the recipe.yaml, it's a little bit larger. If you remember from last time, we have this response schema where we define how our JSON should look like, the response from our Gemini model. And last time we already had the recipe title and a description, and I extended it to the recipe image prompt. So this is what we're getting back as part from the Gemini model. So the Gemini model generates our prompt for the image, and we are taking this and simply sending that to first we're parsing it, because it's need to have this as a proper object assigned, and in the next step we use this as our prompt. But this is, we're getting the output from the Gemini model as an input for the Imagine API, which we're using. All right, looks good. So if you have some ideas, if you want to generate something, let me know. I generate a second one. Generate a sweet breakfast. And because it's hot in Germany, I also want to have some refreshing drinks. I'll do this in the next step. Give it a few minutes. I could open a second window and just run the same workflow step in parallel, so you can have as many parallel workflow runs as you need. So it's nicely orchestrated. Generate a refreshing drink. All right. Let's give it a few seconds. Looks good. Perfect. So we should now have at least 3 recipes in our bucket. Let's refresh. 1, 2, 3. So this is what we just generated. It's really nice. Just run one command and it's generated. You could schedule that, so we could generate a recipe once a day, once an hour. You could call it from G-Cloud. You can send a pub sub message. You can call an API endpoint to trigger those cloud workflows. So it's quite flexible on how you can actually start those workflows processes. So, and last time, well, not last time, yesterday, I used ChatGPT to generate a small UI on top of that. So we generated a small UI which takes all this recipe information and shows it in a more nice way. And we can also check this code. I use ChatGPT because why not, right? Yeah, really well served for generating small applications like this small app here. It's not a Python app, it's a Node.js app, but I think it's not too complicated. We have a server where we have our recipes, so we're getting all recipes back. You see we are using the storage bucket, storage client again, like we use for Python. Now we're using it for Node.js to get all the recipes from a specific folder. We iterate over them. We are passing the content. We are getting the image URL. And we are also generating a signed URL to actually show the image. That's what we have here. And we also have this path for the recipe details page. So you can click on an image or on a recipe and you come to a detail page. That's what this part of the backend is doing. And we're running this as a Node.js application. If you have a look, well, this is all the code we need actually to build this website. And we also have a public view folder where we have the index. So this is basically the main page, which shows a grid of multiple recipes. And you see we have this for each loop here, which iterates over our recipe. And recipe, if we're going back to the server, it's just what we are returning here. So you see we have this response.render. We are telling the model it should render the index view. This is how it works with Node.js. And we are providing recipes as a parameter. So very easy passing it from the back end to the front end. And we also have a recipe detail page where we basically access the recipe details, recipe title, recipe, the description, and a for loop over the ingredients. And there's also the image. Where do we have the image? There we have the image, exactly. Same on the server side. If you're scrolling down, you see we are returning the recipe details to this page. I have this also Dockerized, same steps like before. It's always the same, right? It's always the same process. You first build your Docker container, call this recipe app. You push the Docker container, and after that you deploy it to Cloud Run to actually give this a try. All right, let's go to the Docker file. It's a little bit more complicated, but not really. You use Node. I use Node 14. Again, I define a work dir. I copy the package.json where we have our dependencies defined. And if you go back to the Docker file, we install the dependencies, and then we are running our build for our HTML and JSON, and then we are running the server.js. So if you're not a Node.js expert, it's fine just for having something where you can actually give it a try. So let's deploy this. So we're going into the app folder, same like before, G-Cloud builds, submit, and then dot for running it on the on this folder level here. It takes a few minutes again. And then we are getting it up and running. Getting the output here, but you can also watch it on Cloud Run, wherever you feel comfortable to watching this. So it's now building the application. You see we're running npm install exactly like we have here in this folder defined. Now it's pushing the image to the container registry, and in a few seconds we should have a service up and running. So it's still deploying. So deployment is done. So let's go back to Cloud Run. Remember how we named the service. So we called it recipe app. I'm going to copy this. Go back to Cloud Run. We can search for it. Recipe app. Going to take this. Open up the URL. And here we have our recipes in a very nice overview. Here, if you want to give this a try yourself, I post the link here in the chat. You can just open it and you see the recipes we generated. I will also post the GitHub repo because Google asked in the chat. So this is also the GitHub repo where I'm gonna push the whole code from today into the GitHub repo, and you can give this a try yourself if you'd like to. You can also go to the recipe website and generate it yourself. All right. Lucas wanted to have vegetarian Thai food. All right. Let's do that. Let's go back to Visual Studio Code. Level up. Generate vegetarian Thai food. Oh, let's do this. Moin Christian. If you also want to generate a recipe, post it in the chat. You can give this a try and you can see it on the website. So it's now generating. And Lucas, if you check in a few seconds, you can just go to the link I post in the chat and you should see your recipe here. Maybe you can cook it today. Woo wants some Indian food, so let's also do some generate a typical Indian lunch. Let's see what we get here. Let's generate it. We're going back to the application and I have a look what's actually was generated. We could theoretically extend the app to give all the people on the website the possibility to generate their own recipes, but I wanted to show you how the workflow looks like. I think that's good enough. We could also theoretically initiate the cloud workflow from the website itself. So this is also something which we can do. So Thai red curry is good. Okay, let's generate Thai red curry as well. And let's go back to the app. We already, I remember we already had Thai red curry. So we have Thai red curry. We have some Indian vegetarian thali, all right, some ECC breakfast, and a grapefruit and lime refresher I generated before. So quite nice. There should be now a second Thai red curry. Here we have it. So as you see, the image is not yet generated. That's why we are seeing this here. We probably have some staging folder on Google Cloud Storage. So only after everything is generated, we could move it from one folder to the other. could be one additional step in our workflow. I see it's quite flexible on how you can use those workflows. It's very easy to extend it, very easy to add new steps to it. So we now have 2 Thai red curry recipes and 1 lime refresher. All right, regarding the costs, let's also quickly talk about costs. Let me open up the Imagine pricing. So if we have looked at Imagine on Vertex AI, do they have the pricing here? So Imagine, however you want to call it, you see we have 0.02 cents per image, which we need to pay if we generate this. Regarding the costs for Gemini, so if you go to Gemini, we used Gemini 1.5 Pro. Could theoretically also use Flash, which is a little bit cheaper. And this is based on the number of characters. You see, it's just a fraction of a dollar, a fraction of a cent to actually generate 1,000 characters. We had, what was it, around 700 tokens. So it's even less, right? It's a ratio of 1 to 4 between token and characters. So it's very cheap to generate a full recipe. We could even extend it, maybe add additional cooking tips into the recipe. We could add some deeper description, maybe some nutrition values, and it would be still comparable cheap, even if we are generating more content. Exactly. So far cheaper than my cook. Exactly. All right. If you have any questions, post it in the chat. But I think that's it for this kind of orchestration application. I'm gonna push the video on YouTube. I also push the article at the end of tomorrow, probably, or maybe next week, Monday. So you have everything, the article, the code, everything in one centralized place. And next week I will be on a hackathon, so there will be no stream next week. But the week after, we're gonna probably talk about Gemini Code Assist. So Google's coding assistant for IDEs. I use it in Visual Studio Code, but it also supports other kind of development environments. So give this a try next week. See how well it maybe can explain our code we have done today. See if there are any limitations. We also generate a small application with it. So yeah, as I said, in 2 weeks, next week, I'm not here because of a hackathon, but the week after there will be a live stream again. And we install everything step by step, so you can also give this a try next week with the Gemini Google Code Assist in Visual Studio Code. Right, a little bit shorter session today, but I think it's fine. We have everything you need for your cloud workflow step. The code I push now on GitHub, so if you check back in a few minutes, you have the full code. All right. Anything else you want to know? Post it in the chat. If not, as last time, I wish you a wonderful weekend. See you in 2 weeks. Bye-bye.